We've all been there, in the middle of a job, everything going smoothly, until boom, you're missing a part. United Refrigeration is your one-stop shop for all your refrigeration needs. Use your computer or smartphone to go to www.uri.com at any time of day or night to check stock on your favorite brands, such as Copeland, Sporlan, Carlisle Compressors, Danfoss, Emerson CPC boards and sensors, Carrel, Hussmann Parts, and K2Therm. United Refrigeration Inc. is home to these brands and many more. Looking for information on refrigerant conversions or refrigerant banking? Quick access links on the homepage can get you to the information you need. All approved accounts are able to see live to-the-minute inventory and pricing. Product not in stock at your local branch? No problem. Use the Nearby Stock feature to find a local branch that does have what you need. Are you looking for a branch address, phone number, or after-hours number? That's all available as well. Just click on the branch locator and search for your local branch. Have a model number and looking for a replacement part? www.uri.com/ARP has a vast list of quick pick replacement parts. Just search for the model number of the equipment you're working on and click the Replacement Parts tab. If you don't have an account, click the Register button and we'll have you online in no time. With more than 400 locations in North America, each United Refrigeration branch is fully stocked for immediate pickup. Our branch employees have in-depth technical knowledge, so we can help you get what you need when you need it. Visit your local store or www.uri.com/ARP today. United Refrigeration Inc. has all your solutions down cold.
John, how can you always have the right TV for the right application without carrying hundreds of valves on your truck?
You can carry the hundreds of valves on a trailer behind your truck.
That's too funny. That would work, but how are you going to do that? Maybe there's an easier way.
You can use Sporlan's interchangeable cartridge style Type Q and Type BQ TEVs. Type Q is a conventional design and Type BQ is a balanced port TEV.
Well, come on, I need easy. How easy is it?
Easy as 1, 2, 3.
And it serves thousands of unique applications. So what's the process? How do I put this together?
First, you select the thermostatic element assembly. Then you select the body that you need. Then you select the right size cartridge for the application to get the proper capacity TEV for your application. And then I guess it should also be said you want to actually assemble those into a single valve.
That'd probably be a good idea.
Indeed.
These easy to select and assemble valves mean you're always carrying the right valve for the right job then. If folks want to learn more, what do they do?
You can go to sporlan.com and find more information on the Type Q and BQ thermostatic expansion valves.
I guess that's Jim and John for Sporlan signing off.
First question for August. What's the defrost schedule supposed to be for a 05DM NRG case? Please email your answer to arpgiveaways@gmail.com. Hello guys, this episode is brought to you by Fieldpiece. The tough wireless vacuum gauge MG44 from Fieldpiece is engineered to give you the reliable reading you need and the ease that you want. Confidently measure vacuums with a reliable leak-proof seal. The MG44 can be used with the JobLink system app from up to 1,000 feet away. This easy-to-read backlit LCD offers a graphical representation of the vacuum progress, even in low light or at odd angles. Visit www.fieldpiece.com for information or follow us on social media at Fieldpiece Products. Thanks again and enjoy the episode.
You guys! Enough! Hey, want to hear the most annoying sound in the world?
Hi guys, welcome to the Advanced Refrigeration Podcast. I'm your host, Kevin Compass, with my co-host here, Brett Wetzel. How's it going, Brett?
What's going on, guys? Living the dream, trying to do whatever I can. What do you got going on this week, man?
Oh, I'm just running service and wrapping up a few projects before I start another EMS change out
What are you doing? Changing from what to what?
from Emerson and Microthermal.
Really? They're not all done yet?
No, there's like a never-ending amount of them.
I thought they had everything done for that.
God, no. I probably quote three or four a month.
Is Chicago still on fire?
Oh yeah, I mean it's never not going to be on fire.
Well, I didn't know how hot. Jesus, how hot it still was out there.
It's like it goes from like 60 to almost 100 like every week. So it's just bouncing back and forth.
Yeah, I think our low's been 82 or 85, and then by 10 or 11 o'clock it's up to 100 degrees, and I think today was 104 or 108 or something. I don't know. I've given up. But guys, tonight we're going to talk about HCR doors. They can be, they're essentially air doors, so you can have an open walk-in cooler. This way the door can stay open so customers can walk in and grab their groceries and without having to, keep opening and closing the walk-in door. And there's a little bit of nuances with some of this stuff. So we're going to go through some of the idiosyncrasies that you might need to know in order to adjust these things well. I'm going to start by saying, a lot of times you'll see where the underneath the coil, usually in the big box stores, they have these installed with a low profile evaporator where the fans are directly in the center. And if those doors are not set up properly, it will utterly just continue to screw you.
Let's just start off with like they claim that these doors are 80 to 90% efficient. It's more like 35 to 40% efficient.
You think?
Yeah. I've yet to see one of these properly adjusted perform how they say it's supposed to perform.
I don't know if I totally agree with that. I've had really good luck with adjusting them, and I don't know.
They never work how they say they're going to work. And then here's my problem: you call HCR, you get three different. You get depending on who you talk to, you get three different answers on how to set this door up.
Really?
Yes. I have gotten three different answers on how to set these doors up, and I've done a ton of these, and I want to hang myself every single time I touch one.
So so these doors aren't set up properly. It will either usually end up causing a whole bunch of moisture to build up in the evaporator, and basically the principle on why it does it right underneath the evaporator. Underneath the evaporator coils, more specifically, is because of the dew point. Now, just to remind you, dew point is the temperature at which moisture will start dropping out. So, for an example, because we're all used to this, think of a door frame heater, right? Typically in a supermarket, we try to maintain a 55 degree dew point. And if the temperature of the door frame is less than 55 degrees, that's when you'll start having the moisture and the ice build up on the door frame. Well, this is the same principle that I'm going to explain and kind of use for the explanation of why there's moisture building up underneath the evaporators. So if you were to walk in and let me run some quick numbers real quick. If you were to run in and for argument's sake, let's just say the box is at 40 degrees. Okay. Weather. I got an app on my phone. It's called Weatherfeel. Basically, will tell you what the dew point is based off of your relative humidity and your temperature. So, for argument's sake, let's just say that the box temperature currently is 40 degrees because it's not maintaining down a temperature. We're also going to say that the humidity is exuberantly high. Let's just say it's 75%. that gives you a wet bulb temperature of 36 degrees. Now that means anything under 36 degrees, it will start to sweat. Anything over will not. So the reason why this is kind of important is because if we're maintaining a box, we're typically trying to maintain about 18 degrees saturated to 20 degrees saturated. Now, with those numbers that I just gave, the 40-degree actual dry bulb temperature and the 75% humidity, that gives us a wet bulb temperature of 36 degrees. Well, if our coil is operating at 18 degrees, that's obviously less than the 36 degrees. So we're going to end up, creating moisture underneath the evaporator, going along the evaporator right where the coils are. Now, if we were to get the humidity down to, let's just say, 40%, that gives us a dew point of 31. So that means, we still don't have it dry enough in there. Let's see what happens when we get the temperature of the box down. That gives us a wet bulb temperature of, 27 degrees. So, the lower you can get your humidity, the more the dew point's essentially going to, decrease, which means we can have the evaporator temperature, where it's supposed to be and not get that moisture buildup underneath the evaporators. Anything you want to add to that before we get into the door setup?
No, that's basically this, it. If you keep all the warm, humid air out of the box, then it's going to function more. It's going to function better. You don't want to turn that coil into a dehumidifier. The issue comes in is when these doors are on a box, is all it takes is some 400-pound cow of a customer standing in front of this thing for 10 minutes, and now you have this giant air vortex getting sucked inside the box. Mm-hmm. So here's where the problem is. They put a pallet there. If they put anything there, if anything obstructs the airflow whatsoever, or if any air current from the outside hits the airstream, the whole thing is destroyed and the door non-functions. So then instead of, like a normal box, a little bit of air just coming in there, it just rapidly becomes the sponge of the entire store.
Yeah, agreed. Having a greater temperature than what they spec too on the outside is bad too. When you look at the spec sheet, it basically tells you, what the temperature should be. I think it's usually 75 degrees or below it has to be. Obviously, what the temperature on the inside has to be. Some of these units, are just a ductwork and VFD. And then some of the customers have a separate coil, correct, Kevin?
Yeah. So, the dairy, for them to be using a dairy cooler, they should have a separate coil.
Why do you say that?
Because it provides an extra layer of dehumidification, and HCR even recommends it. So for it to be inside of a dairy cooler, to have that colder inside temperature, they recommend running a coiled HCR door. Now that becomes a whole nother set of challenges with setting up this door, because the whole door setup process becomes more involved, because now you have this coil in here that's adding to the static pressure of the door. So you have to overcome that coil static pressure, and you have to make sure you have enough airflow, because you have to increase the volume of air flowing through this thing now. So you have to increase the volume of air, and you have to make sure the EPR is 100% correctly set. And I don't know why a lot of these manufacturers continue to send out electronic EPRs on these. And you cannot use an electronic EPR with this. I don't care what anybody says. It nonstop leads to issues. That being said, if you get the coil temperature below freezing on this thing, it will frost over, and it will cause a massive slip and fall risk. Because once that coil freezes over, it's going to start raining inside this HCR door. So you need to make sure that you have the coil temperature set, higher. So like we generally run like a 45-degree discharge air temp, 45 to 50 degrees. So like usually no no more than 35-degree coil temps to keep it from freezing.
Okay.
Now, and then the other thing with the HCR doors with the coils in them, the trapping of the drains. I see everybody messes this up. The drains have to be trapped individually. So there's two different separate drains on this thing. There's a supply and a return drain, basically. There's a where the coil would be drained, like where the pan is sitting, and there's a drain pan inside of the blower compartment to catch any carryover, because there's going to be carryover no matter what, because you have a lot of velocity coming off of a small coil. So what I see guys do a lot is they will tee these together and they will trap them afterwards, or they will tie them into the coil drains. You cannot do that. They have to be trapped individually, and then they have to be trapped separate from the actual coil drains, because you have all that velocity pouring in there. It'll actually push air, warm, humid air from the air door right into the coils. And it'll go right into the coil drain pans. And you'll have this huge load put on these coils now, because now they're getting all this humidity straight out of the drain, because you have so much velocity coming out of that drain. It'll push straight pressure, into the actual coil. So these need to have a very deep trap on them to make up for that static pressure that water needs to hold back on to keep that humid air from blowing into the coils. So that's one big thing I see everybody mess up, is the way they trap these. They have to be trapped individually. And then,
so I have a question. So I'm kind of confused. So how many coils are typically in this HCR? Because I've only seen one or two of them, and that was like probably 9 years ago.
There's just one coil.
Okay, so you keep saying that you have to trap them separately. So can you elaborate on that a little bit better?
There's a drain pan inside the blower cavity, and there's a drain pan on the supply side.
Okay. All right.
So the drain pan inside the blower cavity would obviously be the return side.
Mm-hmm.
So, and then the supply side is the supply side. So you got two different pressures there. So if you don't trap it properly, it won't drain right.
Do you know what the static pressure is supposed to be at a maximum across that coil?
I do not remember.
Okay.
All these HVAC guys would love to talk about it, though.
I'm just you're an ass. I'm curious, so you could tell what it's supposed to be. Typically on an air conditioning, coil, you're supposed to have, I think, anywhere from.
Oh god, if you start quoting like things that aren't 100%, you are going to get ridiculed.
That's right. Half to 1 inch of water column, no more than that, because that.
Oh, they're gonna ridicule you.
It's gonna be.
Oh, yep.
It's going to be indicative of the coil actually icing up. Now I'm going to have that. Well, so I don't have any. So next time you're at a Bosco, why don't you measure it across and let us know what the static pressure is without any ice in the coil.
Drill holes in there, and I would be probably strung up and murdered for that. So I mean, generally, like same with these HCR doors, guys, there is a filter in these, and make sure that it stays. There's not supposed to be at that particular customer. There's a filter rack in there. They are not using it at this point, but I have had five of these come out with filters installed in them, and within like a week they're plugged. So yeah, okay. I mean, it's just a lot of volume moving in there. It's easier to clean the coil than it is to change the filter every week. It literally takes a few minutes to clean the coil in those things. I usually just hose the shit out of them with a hose. But generally make sure the coil's clean, and then make sure the supply air filters are clean on the nozzles. Make sure all the nozzles are clean. Generally there's a mesh air filter in there.
So I think the one that you're talking about is the one that definitely has the coil in it. All the ones at the big box stores that are utilizing these that do not have the coil do not have a filter in them.
Correct.
So
they just have filters on the outside. All the ones I've seen.
If that.
They're supposed to have like the filter on the outside.
Yeah, they don't. So on the side that Kevin's talking about, the nozzle side, basically it's the discharge. There are two pieces to this. There is a inside slide damper that has to be set up a certain way before you even start.
Do not touch it from the factory.
What?
Yes.
No.
I'm going to throw it to you the number one thing. Do not start adjusting things on this door until they tell you to. You void the warranty as soon as you do. 100%. You void the warranty as soon as you start adjusting nozzles and stuff.
Not every single customer has HCR actually come out and adjust those doors.
No, they come. So I've had this argument so many times. All those doors come factory preset. So all the angles, unless they get mangled during install, those all should be factory preset.
All
So
right,
the gap should be 2.5 in the middle. Or I'm sorry, 1.5 in the middle, and then it should be. Is it 4.5 to 5?
It depends on each. So the one that I'm speaking of is usually 1.25 in the middle.
They're all the same. Every single.
Then it's 1.25 in the middle and 5.25 at the top. That's the opening gap. But before you do that, you have to set the nozzle on the inside with those slides, the ones that you just said don't touch. The top one and the bottom one are supposed to be 100% open, so you loosen up that 1/2 inch nut that's in there. You slide those all the way out. The one in the middle needs the gap between to be about 1.25 inches, I believe, or 1.5 inches. And then that's when you then can adjust the actual discharge angle nozzle dampers on the outside.
Do not touch any of that. It's all supposed to be factory preset.
Never. I have no idea what you're talking about.
So every single door I've started up, the spacing is always set up that way, and the nozzle is always set up that way. Every single door, the feet or the CFM is wrong, or the door is bent physically the wrong way from guys hitting it with lifts or something like that. Every single door that I started up at Costco, the louvers are preset. Trust me, I've called HCR to unload on them so many times because it says not to mess with it, and then you start messing with it. And I mean, I've gapped them a little more, I've gapped them a little less, but all that is supposedly set up from the factory, and supposedly it voids the warranty messing with it because now you take on all liability for the way the door is set up.
I'm gonna have to agree to disagree. I've never had one that was set up properly, because usually I'll get the call where the box never maintains temperature, and typically the EPR is at 100%, and all the evaporators are sweating inside the box. I've never seen one set up from the factory ever. But those nozzles, so there's a certain way that you have to do it, and I'll post some pictures of how it's supposed to be. But Kevin's correct. It's the gap at the top of the actual dampers that are adjustable are supposed to be 5.25 at the top of an opening, 5.25 at the bottom. There's also a little nozzle with adjustment piece of steel in there that has a whole bunch of holes in it. Typically, you have from end to end, you're going to be one in from the very end. That should get you in the ballpark where you need to be. Same thing with the bottom. And then the one in the middle, you typically only have 1 or 2 of those holes being empty before the bolt goes through to actually hold that adjustment.
Now, here's the other thing. So the top should be curving out of the box. The bottom should be curving into the box, and the middle should be pretty much straight. Now, I've seen this done a multitude of ways. They used to send out marking string. What do you call it? Ribbon. Now,
yeah, it's a yellow ribbon.
If you go to use caution tape, it's too heavy. Mm-hmm. Not going to work. So yellow marking ribbon, Home Depot has it. It's real light ribbon. for market stuff. That works fairly well. My new go-to is toilet paper. So I don't do it how they say that they do it in the thing anymore. So what I used to do, and I still do it on occasion, is I'll tie every 8 inches. I'll tie off ribbon, and do not tear the end. Slice the end cleanly with a knife, because if you tear the end, it'll fuck it all up. I don't know why it does it.
Because when you rip it, you're basically making it more dense at the end.
Yeah,
and it makes it too heavy. It makes it too heavy, and then it doesn't flow properly. And the recommendation I have is, when you're setting up these ribbons, whether you set up 8, I usually set up 3. You have it usually about 4 to 5 inches cut before it actually hits the other side. That'll give you an accurate representation of how the airflow is supposed to be.
So you're gonna feel quite a bit of carryover on the outside of the box when it's set up properly. I've never. They say you're not. Everyone that I've had working properly, there's quite a bit of carryover on the outside of the box. So what I generally do is I take a broomstick, and I will take the ribbon, or I will take toilet paper, and I will take the broomstick, and I will make it like 8 inches, or maybe, like, say if the door opening's 10 feet, I'll make it 8 feet, like 2 feet short. And I'll just carry that broomstick along the outside air current, and I'll watch the way the air current goes. The top should be curving out. The middle should be curving like more towards the straight of the door. And then the forward, or the bottom, should be curving in. Now, generally, when I see these doors set up wrong, it is the same things almost every time. For a non-coiled door, it's 46 to 49 hertz every single time. With a coiled door, it's 56 to 58 hertz every single time. No more, no less. If you're cranking them up more, something's set up wrong with the door, the louvers are in the wrong spot. If you're not making velocity, the louvers in the wrong spot. If they're too low, what ends up happening is you start falling off before you reach the end. You won't make the all the way to the end of the pass. The air's not making it all the way there. It like does this tumble, and then you end up not throwing the air into the box. You start feeling a lot more humidity coming into the box.
Yeah, you'll see the bottom, specifically the bottom ribbon will kind of not be able to make it all the way across.
It's usually the top ribbon is. Every time I see it, it's the top ribbon won't make it all the way across.
Hey guys, today's episode is sponsored by Westermeyer Industries Serviceable Oil Floats. Many oil separators contain an oil float to effectively meter separated oil back to the compressors. Westermeyer Industries has taken this concept and perfected it with their new line of serviceable oil floats. These floats feature an improved design with fewer components, allowing for greater manufacturer consistency and up to 20% increased oil flow versus their legacy models. These floats also feature an integrated magnet to shield the oil path from debris and have been field proven in supermarket applications. Westermeyer Industries offer replacement oil floats not only for their own separators, but also cross-compatible models for our competitor oil separators as well. You can find out more about the Westermeyer Industries serviceable oil floats by visiting westermeyerind.com/floats. Once again, that's westermeyerind.com/float. Let's get on with the episode.
And you said, yeah, so what? I'm sorry. What hertz did you say? I heard something 49 for coil, but on the low, what did you say?
So for a coiled door, it's 56 to 58 hertz. For a non-coiled door, it's 46 to 49 hertz.
Yeah, it depends, man. It depends, because I only went a little bit lower than that. I think 42 is basically my limit. So you're right as far as the top end, but like I've been able to adjust them at like 42. It's a play game. I posted, if you guys do look on the Supermarket Refrigeration Tech Talk Facebook group there, if you type in HCR and my name, you'll see one that I adjust, and you'll see the ribbons and how it was set up as far as what the throw is supposed to look like. Because it's funny, because like Kevin said, the reason why we have the top one forcing out a little bit towards the outside of the box is because obviously heat's going to rise, and the same principle with the bottom one. You want to try to scoop all that cold air in, so you're scooping that in. You'll see the air actually almost do a towards the top and towards the bottom with the ribbon. You'll see it basically doing like a little bit of a C. It'll come in a little bit in the box and then go right back into the center of the door. Same thing with the top. It's going to want to go out a little bit and actually scoop back in a little bit. I believe the angle on those nozzles on the angled adjustments is supposed to be, I believe, about 20%. If I'm not 20 degree angle, if I'm not mistaken. And they have a layout, which I'll also put on there. The document that I have, Form HCR-48D. This takes care of the units that are without the coils, and it actually shows you what the primary air is supposed to be. So when they talk about the primary air, they're talking about the air coming out of the discharge, going into the return across the way, and they'll show you what the secondary air looks like. It's basically the Venturi action that happens with the air on the outside that keeps that air a little bit separated. And they have an adjustment guide that basically will tell you, if your air looks like this, it's straight. If your secondary and primary air looks like this, where it's going too far out of the box, it tells you that your discharge velocity or your angle is too small. You might need to increase the velocity with the hand damper or the VFD, increase the discharge angle or reduce the nozzle width. And if basically it's blowing out too far, discharge air velocity and or your angle is too large, letting too much air, going one way or another. And basically their fixes for it is reduce the velocity with the hand damper or VFD. So that would be adjusting your speed, obviously. Reduce
12 to 1300 or 12 to 1300 feet per minute is like the sweet spot.
Yep.
12, I take an anemometer and I run it up and down, generally 8 to 10 inches from the bottom, 8 to 10 inches from the top, and more towards the center. Hold it straight. I use a Testo one, and generally I'm shooting for like 1250-ish feet per minute, and that generally is a sweet spot. I usually don't mess with the dampers for that. If I'm over or under, I'll raise the drive a little bit or lower the drive a smidge, and you'd be surprised how much, 1 or 2 hertz affects it. It's a lot.
Yeah. You want to make small adjustments and just wait. First and most important thing, like I said, is getting those angles set up as good as humanly possible. And then next step is trying to adjust your speed and seeing where it is and seeing if you have enough throw. And because you'll see sometimes if you have it set too high, it'll start throwing more air outside of the box. Then in turn, I've seen cases across the way from these open air doored walk-ins where, you're washing out the case that's in front of it or on the side of, on the side of where the air is. And you're basically just blowing a whole bunch of air into it, causing high temperatures on another case that's not even associated with the door.
Yeah. The other thing is, I've watched doors, have a rooftop 100 feet away, and it'll be fine. The blower comes on, and it's enough to affect the air curtain. It doesn't take very much to interrupt these things. I mean, if everything is not perfect, this door does not work. That is my biggest problem with them. If everything is not perfect with this door, even including the environment, it's not going to work. So with that being said, if the box is slightly cold, so say if your set point's 34 degrees and you're running 32 in the box, now you're outside of design parameters, and that box is now going to not be able to keep back the humidity. and it's going to draw in more humidity, and you're not going to maintain. So, I mean, that box has to be pretty much on both sides of the door, has to be completely set up properly. You need to be, a 50-degree dew point or less on the store side. You need to be at your set point on the other side. Like I see, for example, Costco, the produce coolers, they run at 40 degrees or 39 degrees is a set point. So I see guys run them down to 37 and then they have issues. Well, that air door is not designed in those boxes to maintain that box at 37 degrees. It's designed to keep it at 39 to 40 degrees. And it can't keep up. The air door can't keep up. You need a refrigerated air door at that point, like the dairy boxes have. I mean, the Sam's Club ones, they sort of work, but I mean, they also have a lot more coil in there than some of these other boxes. The Sam's Club dairy cooler has probably triple the amount or double the amount of coil BTUs than a Costco does.
Oh, and like the actual coils hanging in the evaporator?
Yep.
Not the, yeah, because I was going to say the Sam's Club one don't have the coil within the unit.
There's 6 coils in a dairy cooler at a Walmart. There's 4 coils in a Costco or 2 coils in a Costco.
So another important thing to know about these things, typically you'll see a door switch at the very bottom. And what that door switch is for 2 reasons. One, when you shut that door, it basically shuts down half of the evaporators in that box. So if you have 6 evaporators, it shuts off 3 of them. The other thing it's supposed to do, it's supposed to send a signal, a closure signal to the VFD to put it at a minimum percentage, because if they close the door, we don't need any airflow really going across that thing to, block any air. The door is shut, and we don't need obviously the amount of capacity that we needed. So we shut down 3 of the evaporators. That being said, you have to use a double pull, double throw switch. You cannot team up the input that goes to the IXO module, basically the input module when they're using Novar.
You
and
could.
No, stop.
XIO.
Thank you. So the input board can't share the same input. You can't share the same set of closure on that switch. The reason why is because sometimes the input board, because it has DC voltage there, it will shut down the VFD to the minimum speed when it's not supposed to. That's why you need a second set of open set of contacts on there. I don't know. Like I said, I think it has something to do with the voltage, sitting there on the input. But I've seen intermittently where the door won't be at, the full speed that you set it. It won't be running at the 42 to 49 hertz or whatever. It'll be just running at the minimum, which I think is supposed to be set for 35%. So that's why we can't share that. So make sure you have a separate set of contacts on there. Otherwise, you'll cause an intermittent where the door is not knowing what the hell it wants to do, whether it wants to be at 35% or whether it wants to be at the speed that you actually set it. What kind of VFD is on there, Kevin? Do you remember?
It's a Mitsubishi.
Okay.
Either Mitsubishis or they're the same VFDs that they use in those. Or they're Allen Bradleys. I'm sorry, they're Allen Bradley drives, not ABBs. Allen Bradleys.
Yeah, I can't remember they have a dial on there that's where you set the actual speed, and then in the program itself, I'll find that parameter.
It's on the door.
Yeah. So P104. Okay, they actually have it set for 30 hertz, and the maximum frequency is set for 60. So whenever you do that minimum frequency and you give it that shutdown set of contacts, that's when it goes down to the minimum percent. You freeze? Oh.
Christ. Oh.
It's bad.
With that being said, guys, just make sure that these doors are actually set up the way they're supposed to be. I mean, you can call HCR when you have problems, but this is where I get really frustrated with this, because if you call HCR, you're gonna get 3 different answers depending on who you talk to and how to set this door up. So that's where it gets super frustrating. I mean, different guys at HCR set them up differently, and that becomes a problem. So, and if the door isn't set up right, the box isn't going to function properly. So just take some humidity readings outside and inside. I mean, there's a lot of times the rooftops aren't set up properly. Like customers will just throw these things in a store with no dehumidification, and now this thing becomes dehumidification. Is air pouring into the dock doors? I mean, this is not going to keep humid air out of the box. I mean, humid air is going to go right into that thing, no matter what. It's going to become a sponge. So, I mean, there may be a point to you having building pressurization problems, or you have dehumidification problems. And unfortunately, this door is just not going to work. It's no matter, you can set it up, as proper as you want. If you have high dew points and high relative humidities in the store, it's not going to work. It's not going to function properly. Even with a coil in it, it's not going to work.
So I just found the spec. It's 75 degrees for the maximum outdoor, like outer room temperature, and 60% relative humidity. So it's basically almost like what a Type 1 case is. The relative humidity can be a little bit higher, but I mean, from my experience, as far as Costco's, their humidity in their building isn't usually always the best. How about you? Are they still the same, or they've got that under control yet?
The new stores, yeah, it's under control. The old stores, absolutely not under control.
Yeah.
But Sam's the same way. I mean, most of Sam's clubs are, the older ones are humid as could be, especially if the mutters are broke every week.
Either that, or they're leaving the receiving door open, and it's a wind tunnel from the back of the store all the way up to the front of the store, and there's nothing you can freaking do about it. No matter.
So yeah, it's just going to build. I mean, and then now that box becomes a sponge. It becomes a dehumidification for the store. So I mean, just make sure the doors are set up properly, but don't forget about the environment on the outside. I mean, there may be times where you guys need to force a couple rooftops on, force some heat on in the building to keep the rooftops going in that area, to dehumidify that air a little bit to keep it running. You don't want this box to become a dehumidifier. And then setting up the fan speed, making sure it's at 1,200 feet per minute, and making sure your VFDs are using those percentages I gave out to get you close, and then just tweaking your angles. I mean, a lot of times I've had to pull the tops a little farther out. I'll take a tape measure and I'll make sure I think it's a 1.5 inch gap from top lip to bottom lip from the door face. So you want to make sure that you have that gap from the top face of the door facing out, and then the bottom of the door facing in, and then you should have equal gap in the middle. So you may have to take that and just take it and get up there and bend it a little bit. Just physically just bend it a little bit, kick it a little bit more, give it a little more kick out. That's why I say, I'd rather blow more air out of the box than blow humid air into the box. So I'd rather have a little more carry out of the box and then carry into the box. So, I mean, just take that into account. I mean, you guys may have to tweak it a little bit here and there. But like I said, those doors are supposed to be now, in the last year and a half, they've all supposedly been factory set. And they literally come with a tag on them that say these are factory set, and the bolts are taped. Do not adjust these. This is factory set. Call tech support before moving any forward with adjustments.
So did they just start doing that?
In the last year and a half, every one of them I started up has had all those tags all over it. And I mean, they're everywhere on the top, the middle, the bottom, on every adjustment point. There's literally a tag.
See, honest to God, I've never freaking seen one like that ever.
The problem is because guys go in there and they start messing with these doors and they get them so far out of whack that, guys spend a day or two trying to fix them. So they get so far out of whack, so they don't want you. They put them all in one spot, and then when you call tech support, they tell you to mess with it. But make sure you get their name, because what I found is you'll call back and they'll be like, "Oh, I don't know who told you to do that. That would be one of us." It's like, no, this guy literally just told me to do this and told me, well, the other guy doesn't know what he's talking about apparently, because he's telling me to do it this way. I'm like, what is going on here? This is chaos.
Well, they have some really good videos. I don't know if you've ever seen them on the HCR Jameson website. There's videos that give you a brief overview on how to adjust these things. Like I said, I'll be posting a whole bunch of information, whatever I got, onto the Advanced Refrigeration Podcast Facebook group, so you
What about
guys
that
can see.
70s video, like with the guy with the blue hard hat, where it's like, it looks like that 1970s safety video?
Yeah, I think you're absolutely right. Actually, 100%, 100%. That's the exact video. I mean, but it's
good. It's a decent video.
Yeah, I had a guy was making fun of me because I was putting up pictures on one of the posts about me adjusting this door, and he puts up like the Napoleon Dynamite where he's dancing with the fucking ribbon where it looks like a ballerina just busting my balls. Brett adjusting an HCR door. By the way, don't do this while you're during business hours. If you need to adjust it, come in stupid early in the morning and adjust it then, because trying to adjust it while you have people walking through that thing constantly is the most aggravating thing ever.
Yeah, that's why I do it with the stick now.
The stick.
Yeah, I use this. I don't run the ribbons across the door anymore. I use a stick and I run the ribbon. I hold the stick in my hand, or I put the ribbon on there so I could move it around wherever. That's how HCR tells you how to set them now. Like that's
Really?
how. They don't want you to tie off to the door anymore with ribbons. They want you to take toilet paper and wrap it around light toilet paper, wrap it around like a broomstick, and they want you to find the air curtain that way.
Yeah, I'm gonna do my Swan Lake.
To be honest, the stick works a lot better because
Really?
because you could take like a 3 or 4 foot section, and you could just take the stick with you, and you could just walk a little bit more, and you could see the air curtain more when you get towards the end, where that you may be falling off, because the length, you could see the air curtain a little more. I've used smoke pens too. Like I've literally fogged one of these doors to see like how bad the airthrow is, and it helps big time. But obviously you can't fog a door during store hours.
How do you, man? So like, are you
Smoke
lighting the
machine.
whole? Oh, okay, all right. Well, you said, hold on, because you said smoke pen. I'm like, I was like, I can't even really fog out a case with a fucking smoke pen. So I was curious on how you're
Really?
doing that.
I use a MAP gas torch and a Milwaukee leaf blower with a smoke pen, and it usually makes a shit ton of smoke.
Really?
Oh yeah, like a shit ton of smoke.
Huh. Yeah. So I just looked up those specs. 5 to 5 and a quarter at the top, 5 to 5 and a quarter at the bottom, and 1 1/4 inches in the middle. And wherever the leading edge of that piece of metal is that you're using for the nozzle, the diverter, needs to be a 1/2 inch from the top edge over towards the actual door frame, and that goes the same for the bottom section. Like Kevin said, unfortunately, those pieces of metal that they use with the holes in them to set the doors up aren't actually exact as far as, you set it to this, it'll give you this gap. It's not the way it is. So sometimes you just have to legitimately just bend it out. Like if you're only getting, 4 3/4, well, it looks like I'm just going to bend that just a little bit. And it works. It works good.
Just don't be a jackass and just like bend the living shit out of it, because I've seen that too.
No, like I said, I'm gonna post some pictures up on the website, and I guess we'll go from there.
Yeah, I mean these doors are relatively simple, guys. Just don't let it get the best of you. I mean they get pretty frustrating at times, but just make sure everything else is around the door is working properly before you go like bananas on the door and start adjusting a million things, because generally it's going to end bad for you and it's going to make your day worse. So small adjustments first.
Yeah, the one last thing that I want to bring up. So typically when you do finally get these things adjusted, you will notice a significant difference. Like if you have a box that's really high humidity, you go to breathe in the box, and you're not getting can't see your breath. Once you start getting these things adjusted, it'll get stupid cold almost instantly, and you'll start actually start trying to see your breath. The other thing is if you graph the EPR percentages, that will also give you an indication whether you're on the right path or not. you'll typically see the graph just start to bury, and actually instead of being at 100% constantly, it'll start coming down to the 20, 25, 30% range.
Electronic EPRs with air doors are the worst idea ever.
Why
Even
is that?
box, because you can't control the coil temp. So this is why like Costco's like, I think their ways of doing things are a lot better now. Like they control all the boxes off, all the coils off coil temperature now. So they're actually controlling it off a saturated temperature. So that way, when the EPR opens after defrost, it's not opening wide up and frosting the coils over, because that'll happen. I mean, if you go wide open on those dairy coils post defrost, and you're running say like a plus 15 or plus 18 rack, you're going to ice the coils over instantly. Because I mean, the box is it's going to run a higher RH than a normal box. So you're going to ice those coils up. So you need to have a pull down percentage in there, or you need to somehow be controlling the saturated temperature. Because if you are just running off a return air temp, I mean, I see it all the time at the Sam's Club ones. The coil where the door is blowing into the box always ices up, because that coil is generally 80 to 90% open, because it has more load on it, because that area of the box is going to have more load. So that's going to cause that EPR to open up more, and that's going to cause the saturated suction temp to lower, and that's going to cause the coil to ice. And it's this vicious cycle. Once it starts to get a little bit of frost on the coil, then it starts spitting water, and you're out there for generally a water leak. You have some water coming off the coil in the low profiles, because once that little bit of frost gets on there, it starts spitting water out of the coils. So generally you can adjust the door, but I mean, that's almost a design flaw issue with these doors. I mean, on that door side coil where it blows in a little bit, you're going to have a load increase. So not being able to control them off saturated temp, which I think the Sporlan SC3 ones are controlling off of, at least the ones I've done, they are controlling the evaporator saturation. The early ones were just controlling return air temp, and those ones had the icing issue.
And also remember those coils. We talked about this before, but we always say 6 to 8 degrees for medium temp superheat on those low profile evaporators. Especially Bone and Heatcraft is the manufacturer I was talking to specifically. But you'll see, if you don't have the 3 to 5 degrees of superheat that they recommend for those particular coils, you'll have icing on the coil side that is opposite of where the pipes enter for the expansion valve. This is the reason for this is because the distributor typically on those size evaporators have about 10 distributor tubes. They're not point down, the distributor's actually pointed to the side, probably because of lack of space. And if you don't have enough refrigerant flow coming out of your expansion valve, the refrigerant's going to follow the path of least resistance. So if the distributor is sitting on the side where it's just shooting straight out and you don't have enough refrigerant, obviously that refrigerant is going to go to the lowest point. Well, the lowest point on that particular evaporator is the coil on the side of the expansion valve, where basically the top part of the distributor is not getting any refrigerant. So the coil on the left-hand side is clear, doesn't have anything on it, but then on the right side, you'll have a copious amount of ice. So just be aware of that as well. The superheat on those particular evaporators does have to be lower than what a typical medium temp coil needs to be at. And make sure when you're looking at it, making sure that the evaporators are clear. Because like Kevin said, if you have any ice or any kind of debris on those things, what really happens is if you're blocking part of that coil up with ice, you're decreasing the amount of space that the air can go through that coil. So if we decrease that amount of space, then it picks up more velocity. So like you said, that's when it starts spitting the water directly out of the damn coil. And you've seen them where they're usually typically measuring return air temp, correct?
Yeah, correct. They're measuring return air temp. So, but the SC3s are measuring saturated suction temperature. And so is Microthermal on the newer stores. They're doing using transistors, and they're controlling the electronic EPRs off that. But if you don't have the ability to do that, you're better off having an A8 style EPR, like a standard EPR, where it's just going to be set to control saturation and that's it. Because if you're dipping down too low, you're going to ice the coils over. That's where electronic EPRs really don't do good at. Like it's not the EPR, it's the control strategy at hand, because they're controlling return air temp. It's just not a good application for that. If you had a better control strategy, it'd be fine. Like if you're controlling off saturation, it's fine. It works great. But in that sense, I'd rather have mechanical EPRs because they cause less problems.
Unfortunately, all the ones I've ever seen are all electronic for all those.
It's 50-50 with us. So with Sam's, obviously, it's all electronic. Costco, it's 50-50, depending on the store, what's there, depending on how the remodel goes. But yeah, there's a lot of stores going to these. Pretty much every Sam's and Costco in the country is going to have an open air dairy cooler. I mean, it's the new rave. I don't know. Me personally, I don't like shopping in a cold cooler, so I don't get the whole nuance behind it. But it's easier to stock and easier to sell things out of, apparently.
Well, I mean, you just said it. I mean, you don't have to stock it nearly as much. They basically, pallet's empty, bring in another pallet, done. Instead of having to waste the time of the person just stocking all the shelves or the rear load or whatever the hell they have, right?
So they run into stuff.
Yeah, that's the only thing. You guys will notice as you do more service on these things, you will see that the doors occasionally, like at least once a month, get hammered.
So take a brand new one at a Sam's. We literally just turned a box over to him, straight masked up forklift hit. The dude hit from front of the box to back of the box. Like he bowed the whole door piece, the whole structural steel for the blower. Like it was violent.
Yeah, make sure you adjust when you're done adjusting these. Make marks on wherever you have it. Nail polish works, so you can adjust it so you can see if the bolts were ever broken free. So just keep that in mind, and maybe even take a picture of how you had the door set up as far as the angle. That'll help you readjust it. Then if when it's inevitable, it's going to happen. They're going to hit the freaking door. And if they don't hit the door, the customer's going to hit the door. Someone's going to hit the damn door.
Yeah, I mean, I usually take a paint marker to them, just a white paint marker, and I'll mark the threads on the bottom, not on the top. So I'll mark the threads so that way you can see if somebody spun the bolt loose or whatnot. But yeah, generally, they have a Ballard there, but usually the customers will knock shopping carts into them. You'll find them off a little bit here or there, just bend it back, or you'll find a fork straight through the thing, and at that point you're just like a body shop at that point. But all right, guys, I think it's enough talk about HCR air doors. So all right, guys, have a nice night.
Later, guys.